All right, well, welcome to tutorial 2, where we'll be getting an overview of Maya's Python API and how we can use it to perform some procedural tasks. By now, we've had a bit of a review of the Maya features that we've used in the past, but now we're going to dive into some coding and how we can script some tasks and come up with some interesting procedural workflows. All right, so the first thing we are going to need to do here is just reorganize our layout so that we can type some code. So we are going to go to the panels menu here, and under saved layouts, we're going to find a script editor and perspective setting. Okay, so this creates a script editor right beside the perspective camera view. So this is exactly what we're going to want for this course, so that we can type our code and see what 3D models we create with it. So by default, you will be set to the Mel tab here, and well, the first most important thing you need to know is to switch this over to your Python tab. If you start typing your Python code into the Mel tab, it won't execute, right? Mel is the older scripting language that originally shipped with Maya. And well, now they have a complete Python implementation. And so we'll be focusing on Python in this course, as it is the more universal language used to extend so many multimedia applications, and also incredibly useful even on its own, right? Python's a great language, and so it's great that we actually have an opportunity to work with it a bit in this course. So the first thing we're going to need to do is import the Maya commands module. All right, so we will use the Python import command. We're going to type out. Actually, I'm just going to zoom in here just to make this nice and large. Hopefully that is nice and viewable on the video playback. So we are going to import maya.cmds. That is the name of the module that is installed alongside your Maya installation. However, we are going to refer to this module as CMDS. That just makes it a bit easier when we are accessing specific Maya commands. We're going to be writing like CMDS dot whatever, just using dot notation to invoke some functions and so forth. It'd be a bit annoying if we had to type out maya.cmds every time, so we'll just shorten it to CMDS. All right, for anyone not familiar with Python, comments can be created with the number sign. So this is a single line comment. And then there's actually a trick for creating multi-line comments. You can actually use 3 quotes beside each other to begin and end a multi-line comment, just like that. All right, so that's a pretty important thing that we need to know, how to make comments there. So with that out of the way, let's just run through a few other quick basics here. Obviously, this isn't a programming course. You already know how to code, so we'll just quickly touch on a few of the important Python things that we need to know in order to effectively use it inside this course. All right, so in order to display text to our console, right, this area right up here will act as our console, and will display whatever we print to it, which is, of course, something we do all the time in programming. So we can use the print function, if I could spell, right? We could use the print function to display various variables and strings to the console. And actually, I should note here that while the print function, or using this as a function with this syntax, it is a Python 3 thing. Maya uses Python 2.7 and various features such as, using print as a function were backported to Python 2.7. So yeah, we are using 2.7. I know I hear the groans erupt as you're watching this video, and I feel the same way, but it is what it is. And that's what we have to work with. But thankfully, we can do some Python 3 things, such as using print as a function. All right, so yeah, let's do our hello world. All right, so just putting a string literal into some quotes there, we can display this text to the console. All right, how do we execute this code? You are going to find a few buttons up at the top of your script editor here. All right, so this is an execute all button, so that will work just fine. That will keep your code in the editor, and well, it first displays everything, and then it gives you the results. It's kind of weird. We get the results printed directly after having the script kind of displayed again for us to see. There's also this single execute button. You probably don't want to use that because it actually removes the code from the editor, which, well, thankfully I copied the code before doing this because you can't Control Z to get it back. So yeah, pressing the execute all button will work quite well. The thing that I usually do, just because my hands are just always busy doing keyboard shortcuts, and I don't like to me it often takes too much time to actually go and click on a button in the UI. So I prefer keyboard shortcuts for most things. If you select everything and do a Control Enter, that will also execute the code, right? So select everything. Actually, let's just clear the oops, that I clicked on the wrong button there. Let's bring back both panels. I want the clear history. Okay, so clear the console. That is this button up here. Kind of handy in some situations. Select everything, Control Enter, and that will also execute the code. That's what I usually do. Okay, so with our hello world out of the way, let's just create some variables here. Right, so no declaration statements in Python. Right, so I'll just make some string variables here. I'll just put my first and last name in. All right, so we got some variables to work with here. And let's quickly just see how to do some string interpolation. Well, actually, let's start with concatenating a string together. This is probably going to be extremely tedious depending on what string you're trying to put together. You know, if it's just two values, I will often concatenate just two strings together, just out of convenience, because you know, why would we? I'll show you this format function that we'll use for proper string interpolation. Yeah, so let's actually just start with the concatenation real quickly to remember how to do that. So if we were to try to print, I don't know, my first name and last name together, we could use the plus sign as the concatenation operation here, and just get that put together. But of course, you know, we run into stupid quality of life issues where, well, we don't even have a space in here, right? So wouldn't it be great if we could just have this formatted in a string and have it a bit more, you know, easy to write, right? So let's do some string interpolation. Again, this is a Python 3 thing that was backported to 2.7, so thank goodness we have this feature. So inside a string literal, we can put in some curly braces. Actually, let's just start with one. One set of curly braces inside the string literal, and then outside the string literal. So I got my cursor to the right of this closing quote. I'm going to do a dot format, call the format method here, and I am going to pass in as an argument first name. So basically, actually, let's just run it to see what it does. Okay, so this has printed out hello, Jeff. That is me. So what it's done is it has formatted the preceding string literal by substituting the argument variable first name into these curly braces that we just specified, right? So location and value, pretty straightforward. Let's do it with 2 values, just so we can see that using a comma-separated list of arguments, we can substitute in multiple values. And you know what? I'm also going to zoom in on this console output because I imagine that was a bit hard to see as well. All right, so there we go. Hello, Jeff. Datama, there's me. And there is our proper use of Python's string interpolation features. So with that out of the way, let's store a vector, right? Let's do some work with numerical values. We've talked about this thus far in the course. So let's just get a brief sense of how we'd start working with vectors inside of code. We're going to do a whole lot more on the mathematical side of things later on, but let's at least start by getting a handle on this. So let's just make a section here. Vectors and storage. All right, just make some empty space. Okay, so let's make some variables here. Let's say x is equal to 1.0, y is equal to, I don't know, 2.5, z, let's put that equal to negative 3.0. All right, and we can print out these values, x, y, and z. So there they are, printed out to the console. But, well, we know that vector components belong together. We usually do vector operations on them, right? And so we'd want to consider these values as components of one vector. So why don't we create a Python list and use these values as elements of that list, right? So a list is basically the same as an array. It's your version of C++ arrays, all right? So let's just assign these values to the first 3 elements of this new array here. Again, no declaration statements or anything in Python. We just specify the square brackets and it knows that we're talking about a list. All right, so now we can, in this case, just print out vector, right? So I'm just printing out the vector itself. We can see the square brackets here with these 3 elements, and of course, we can access individual components as need be. Okay. Well, we have written 24 lines of code here. It would be a wise idea to save this script, right? So let's go ahead and do that. I am going to hit the save button and just save this somewhere that makes sense. Call it 202.py. And so .py is your file extension for Python scripts. And we can just save that. All right, I will just make quick mention of this. I'm not going to do this in the tutorials, but I will make a quick mention of it. A lot of students don't like this text editor, and I don't blame them. It's pretty bad. We can do basic stuff like tabbing multiple rows and stuff like that. But if you are sufficiently not a fan of this text editor, an alternative way of coding inside of Maya will be to have a text editor open on the side and just have this script, the one you got open here, you're just going to have this open in the text editor. And then we can code in here. So I got VS Code open here. And, we could make some updates. Maybe, I don't know, let's print out element 0 of that vector again, right? So now when I save this file, the only thing that happens is over in Maya, it says, okay, the file has been modified. Do you want to reload it? So we say yes, and then the change shows up there. You can go ahead and run it, and everything works just fine. So if it would significantly improve your experience using Python inside of Maya to use an external text editor, go right ahead and do it. That will work just fine for you. However, I've gotten used to working in this rather primitive text editor, so I'm going to continue to do so just because I want I only want Maya on my screen just to maximize user interface real estate. All right, so we're going to move forward here, try and keep this tutorial as short as it can be. And let's just quickly create an object for vector storage. Let's just do that real fast because, well, in most situations, we'll probably just use a list to store vector values. You might want to create a class for vectors or perhaps other types of data. So just to quickly show off the object-oriented side of Python, let's create a class. It's called vector object. And this is where the kind of weird looking code block syntax of Python kicks in, right? For those of you coming from C++, we're not doing code blocks in curly braces in Python. What you do is you put a colon on the end of your line and hit enter. It's automatically going to tab you over, but the way it works is that tabs actually define your code blocks. So you have to pay attention to your tabbing and code very cleanly. It's very easy to get your tabs out of sync and get all your code blocks messed up. So, well, if anything, this will enforce some pretty clean coding standards, which, hey, it's always a good thing. So no harm done. So inside a class, we do need an init function. So we're going to use the def keyword, that is for defining a function. The name of the init function is __, init with a lowercase I. And then as parameter, we pass in self. This is just a reference to the object itself. Again, we define a new code block, put the colon in there, and then, well, thankfully Maya is actually smart enough to tab us over when we hit enter. But, well, we are defining a function here, right? So we've created a new code block. And then to declare, and in this case also define properties for that object, we are just going to say self.x, right? So I'm going to create an x property for containing an x component. We can set its default value to 0. Self.y, let's put that at 0. And self.z, we'll also have that set at 0. All right, so I'm going to make sure I tab all the way back to kind of the root level of the script. Let's instantiate this class. I'm going to create a new variable, new vector, and that'll be equal to, and in this case, I'm going to call the constructor for the object vector object. And then, so let's just make sure we didn't make any mistakes there and that this runs just fine, right? So no errors. Always a good idea to just run your code, make sure there are no errors. And then, well, we can print, we can just print out these values yet again. So vector value, I'm going to use some string interpolation again to just quickly format this string. So we're going to insert, I'm going to need some more space here. right, we're going to substitute in new vector dot x, new vector dot y, and new vector dot z. That is a long line of code. All right, let's just, oh, I made a mistake somewhere. So let's just quickly see what I did here. I missed my parentheses on the end of that line. And so that'll work just fine. Okay, so hey, maybe we'll put some square brackets around those vector coordinates, right? So I mean, currently the vector is set at 0, 0, 0. We could change those values if we want. All right, so that gives you just a quick rundown of creating various types of data inside of Python. And now let's start working with some 3D objects. Okay, so let's create a cube. Make a new section here. Let's create a cube. So the command for creating a cube, and actually the commands for creating really any primitive are all quite similar, but we are going to use cmds.polycube. Okay, so cmds, again, this is a reference to the module that we imported, cmds.polycube. Let's run that. Okay, so that has created a cube in our 3D scene. Well, we can't really go much further here without talking a little bit about where to find information on these API calls, right? Because using Python is one thing. It's going to take a little bit just to get used to perhaps using a new language. Maybe it's the first time you've used Python, or maybe it's been a while. But the other thing that we are going to have to wrap our heads around in this course is actually using this entire API that we have never used before, right? So we're going to need some reference documentation. So let's look at exactly where to find that. So just do a Google search. The method I would recommend for any reference information on the Maya Python calls is to just do a quick Google search for Maya Python and then just type in whatever you're looking for. So Maya Python polycube in this case, and you're going to find various pages on the Autodesk website. So here we go. Here's the polycube command. And the only thing we're going to want to make sure that we verify is that we are looking at the Python version of the command. There is a MEL version for every command. It will say up in the top left. So you just need to make sure you are looking at the Python syntax, otherwise nothing will make sense. So on this page, we can see some useful information about this function call. You can see its return value. And then probably the most important thing we are going to be looking for are the types of arguments we can pass into the function call, right? So we'll take a look at these in just a second. But also down at the bottom, you're going to find some helpful examples. So just some short little scripts demonstrating exactly how to use it in case it's a little bit confusing. So let's move forward and define some different types of cubes, just with different parameters. So let's do it with this one. Let's change the dimensions right when we create it, right? So we're going to change the width, height, and depth. And you're going to see here that every argument that you can pass into one of these API calls has a long name and also a little shortcut. So like width can also be condensed to just a W. So you can use either the long or the short names, and they do the same thing. So I'll start here with having my new cube. We're going to have its width set to, say, 2 units. Its height, we're going to set that to 3 units. And its depth, we'll go with 0.5 units. So something you're going to want to pay attention to is to make sure you start with a clean scene every time. Every time, there's our new cube, right? But if I run this script again, well, I've actually created another copy of that object. So just make sure you clear out your scene before you run the script again. All right, so there is a cube with some different starting values. We could take this even further, and let's define, we've got subdivisions on the X, the Y, and the Z axes, right? Such as how many edge loops have been inserted on each of those axes. So in this case, I'm going to use these shortcuts. So SX equals, and let's put a value of 2 for the X, SY equals, let's go 4, and SZ, well, let's put a value of 1 there just to see what happens. And there we go, right? So we've got, we'll see here actually that you get 1 less than the value you put into each of these arguments. So we have 1 division on the x-axis, 3 on the y, and actually none on the z-axis. There is no extra subdivision here. Something we are going to need we're going to need to basically keep track of different objects inside of Maya after we create them. Because just as it stands right now, if we deselect this and move on to creating something else, actually, let's do that. Let's do another one. Let's do another cmds.polycube, and let's just go subdivisions x for, let's go 4 subdivisions on each axis, just to get a different looking object. All right, so there it is. There's another object that we've created. But it's going to be quite difficult actually to select this object that we had created previously. It does have a name. We can actually select it by its name. However, we'd have to store that string value pcube1. Like we'd have to keep track of that in the program and then use it later and select stuff by its name. And it's not really the most efficient way of working. It is far easier to simply take the return value of something like a polycube command and store that to a variable. So I'm going to say cube A is equal to this right here, the first polycube, and cube B is equal to the return value of the second command. Right? So remember, when you call a function and either print its value or assign its value to something else, you're grabbing that return value being returned out of the function and storing that in a variable. Let's actually check to see what that return value was. It's kind of helpful to see what you got out of the function and what we're storing. We're going to run into some technicalities in a little bit that requires an understanding of what we're actually storing here. So let's actually print cube A, take a look at what we actually got returned there. We're going to see this rather strange looking list here. I believe the U stands for Unicode. I'm not 100% positive on that, but I believe it means it's a Unicode string. But other than that, we just have 2 string values. One is the object name. The second value is the name of the node that was created, right? So the polycube1 actually corresponds to the input node that was created for this in the creation process of this object. So now we're going to run into this in the future, but when we want the object name itself out of a Python variable, basically a Python reference to the object, we're just going to take index 0. And that will get us the first element out of that list, which is the name of the object. All right, so with that out of the way, let's move on to actually performing some operations, actually some transformations on this object. Now you can look up to, or these objects, I should say. Now you can look up all these commands on your own time if you like, but again, I'm trying to keep this tutorial as short as possible. Looks like we might be getting up over 40 minutes here, but I'm going to do my best to get through this. So let's do a transformation on cube A. How about that? Okay, so let's make some more space here. Okay, so let's, well, as it stands right now, we first create the flat cube and then we make this other cube. So let's see what happens when we do a cmds dot move, and let's move this object 0 in the x, 4 in the y, and 0 in the z. All right, let's see what happens here. So the cube-shaped cube has been transformed. All right, now it seems kind of arbitrary, right? Why was this cube transformed and not this cube? Well, it has to do with the fact that when you use a something like, or when you perform some kind of operation, whether it be a transformation or maybe some polygon modeling operation, the operation is performed on the object or objects that were last selected. So if we want to control which object is selected, well, then we're going to have to use some sort of a select command, right? So let's do that. The command in the Maya Python API is simply select, nice and straightforward. And thankfully, we can actually pass in as an argument to select this variable itself, right? Remember, it was that strange looking list containing both the object name and whatever nodes were associated with it. Well, turns out we can just pass in that list itself, and it is going to select that object that you were referring to, and then whatever, like I said, whatever subsequent operations you perform, well, they're going to be performed on the selected object, right? So in this case, this cube was left alone, but instead we've transformed the original cube. And yeah, let's just do another quick example here. We're going to do another select and another move. This time we're going to select cube B, and we're going to move it actually using the vector that we stored. Oh, we didn't actually give this a value, did we? Let's actually store a vector value up here. I'm kind of jumping around a little bit, but let's go back up to, I guess that was line 32 for me. Let's store some values in this vector. New vector.x, let's have that equal to, well, let's use these values up here, right? So that'll be equal to x. Right, so we'll use these x, y, and z variables that we had originally stored. So we'll just set the x value to x, the y value to y, and the z value to z. We print that out, we can verify that that vector value was set correctly. And well, I mean, it's, oh yeah, that was using the 040 transformation. So in this case, let's move that cube B, right? That was the second cube we created it. Let's move it to new vector.x, new vector.x, new vector.y, and new vector.z. All right, so this just gives us a little bit of experience using a vector value when performing a transformation. at least using these handy little functions that Maya provides for us. All right, next we need to talk about selecting and transforming components. Selecting and transforming components. So, we're going to spend a lot of time messing around with individual models and actually doing poly modeling operations. So we're going to need a way of selecting individual components and doing stuff to them. So this is where we're going to learn something real handy about Maya. So it turns out that every single thing that you do in the Maya viewport, the operation, or at least the mel command for that operation, is shown in the console. So you're always going to want to have this up, right? Like even like transforming an object, anything, right? It's going to look a little bit weird because this is mel code. Unfortunately, it doesn't give it to us in Python, but we are going to get a sense for what just happened. All right, so we are going to need to select individual components. So I want to select edges in this case. So we can see here that individual edges are referenced by the string pcube1, that's the name of the object, .e, and then it's an array, right? So e, this one was index 34, this was index 32. So let's, actually, you know what? We're not even going to select edges. We want to select faces. That would make a bit more sense for because I want to extrude something out. So we're going to select some faces. We're going to see that this one is called face. It is the 9th index, and this is face 8. So we are going to use that information for selecting these components. So we use a cmds.select in order to do this. However, and in this case, let's do a concatenation, actually. You know, it's probably going to be faster to do a concatenation as opposed to doing the whole string format thing. So in this case, well, I guess let's do a concatenation. So we first need the name of the object. And actually, that is cube A, my bad. Cube A, that was the name of the list that we stored that object information in. So remember what I said, index 0 is where the name of the object is stored. And we're going to concatenate that with .f 8. Let's start with that. So .f 8. So it looks a little bit messy, but it'll work just fine. So there it is. We can see that face has been selected there. And we can even select ranges of consecutive values. So, well, just because face 8 and 9 are right beside each other, our selection is going to be name of the object .f 8 8 through 9. Right, so that's what that colon means, and that'll select both faces. So with these faces selected, let's first transform them. Let's do a rotate in this case. We're going to rotate 0 on the x, 20 degrees on the y, and 0 on the z. And there we go. All right, so with that selection, we have gone and just given it a rotation there. Let's move forward. I'm just going to keep powering forward here. I want this tutorial to be fairly short and to the point. So next we are going to extrude the selection. All right. So so what I said about, everything you do in the viewport is reproduced in the console. I mean everything, right? So if we do an extrude, we can actually see at least the mel version of the command, right? So if we're like, oh, I have no idea what the Python command is for doing an extrude, well, at least when we do the operation in the 3D view, well, we can see, polyextrude face. I wonder if maybe there's something online related to that. So I'm going to go to Google and I'm going to say Maya, I should say Maya Python polyextrude. I don't know, polyextrude. And there it is, polyextrude facet. Right, it's a little bit different, but that's the Python command, and we can get at all the relevant information right here. Okay, so trust me, a little bit of Googling will help you out big time when it comes to figuring out how to do various operations inside of Maya using Python. All right, so let's use that, what was it, polyextrude facet. And again, I'd encourage you, just Google all of these commands. I know it's overwhelming, but when we're done with the tutorial, go ahead and just Google all of these commands and just take a look at, the various arguments you can pass in and try and relate it to your understanding of how we do manual modeling inside of Maya with these tools. All right, so polyextrude facet, and we're going to specify the translate. Well, that is going to be equal to, it's going to be a tuple. A tuple is just an unchangeable list, right? So tuples are specified in parentheses, whereas lists are specified in square brackets. So we need to pass in this 3 tuple to this translate argument. Again, it's just XYZ coordinates. So we're going to translate 1 in the y-axis. 1 in the y-axis. Right, so there it is. Right, so we've taken those faces on top. They were still selected, right, after we did that twisty bit. They were still selected, so we've just extruded them up. All right, now we're going to select some edges and do a bevel. I'm just trying to go through a couple common operations here just to help you get a sense for how we use this. So we can see that, well, that is edge 66, that is edge 62, so we need to do another selection here. All right, so we're going to need to do another selection. In this case, it is going to be, so the name of the object plus dot e square bracket. So that's going to be, let's start with 62. Now these edges are not consecutive. So we can't do 62 colon 66 because that will select everything in between. However, we can just comma separate multiple selections, select 62 as well as 66. All right, so let's get rid of this. Let's get rid of everything here. And just do that. So it's a bit hard to see, but well, we can actually see that's edge is orange, it's selected, as well as that one right there. All right, so we have those edges selected, and let's bevel them. So as you might imagine, it's kind of funny actually. You can start to guess some of the names of these functions. So polybevel, that'll give us a bevel, and let's do a 4-segment bevel. The segments equals 4, and let's keep the offset at 0.5. That's the default in the 3D view. Right, so there it is. That kind of rounds off the corners. Again, I happen to know this because I've done this before, right? But just go ahead and Google the command. All the information is online. And after the bevel, oh yeah, let's do a Boolean. We're going to do lots of Booleans as we do some procedural modeling. So we should just quickly see how to do that. So in order to do a Boolean here, well, first we need another object with which to perform a Boolean operation. So let's create a cylinder. Let's punch a hole in this strange twisty object, right? So cylinder A, let's have that equal to cmds.polycylinder. All right, this is how we create a cylinder primitive. Its parameters are a bit different, right? Because it has a radius value. I'm going to use the shortcut R, right, to specify that the radius will be 0.5 units. All right, so let's see what that looks like. Oops. There it is. It's down at the bottom here at origin. We should probably rotate that. So, well, it is currently selected, so we can just go ahead and cmds.rotate 0, or sorry, this is the x-axis. So that'll be a 90-degree rotation on the x-axis, 0 on the rest. There it is. All right, guess what we're going to do next? We're going to move it. 2.6 units on the y-axis. I just want it positioned nicely at the top of our twisty object. My transformations are a bit off here. Let's change that. Let's try 5.0 units. That's what happens when you don't follow the script. You get all messed up. There we go. 5.5 units puts it exactly where I want it. And now we do a Boolean operation. So, I mean, again, I can test this by just doing the thing, by just doing the modeling operation inside the viewport. I mean, we have no idea how to do a Boolean in Python, so I just do it as per normal. And I see in the console here that poly C bool op, kind of a weird name, but it is what it is, and that's what we use to perform a Boolean operation. So again, you can Google this on your own time, but we can just go right ahead and call cmds.poly C bool op and specify that it is going to be between cube A, that's the twisty object, and cylinder A, if I could spell, cylinder A. And our operation, well, of course, there's 3 Boolean operations. There is union, difference, and intersection. So it turns out that operation 2 is the difference operation. Again, you can find this information in the reference material, the reference documentation. But that is how we would reproduce that Boolean operation using Python. Finally, we are just going to triangulate this object, because well, if we're just preparing a poly model, either for maybe a game asset or a concept asset or something way far in the background where we can get away with using poly models, triangles are definitely the better option as opposed to n-gons, right? With these being some really nasty n-gons. So let's go ahead and, well, with this object still selected, we can do a cmds polytriangulate. Don't need to pass any arguments into that one. That will triangulate the object nicely. And, well, remember that usually we remove construction history after finishing modeling an object. So let's actually run the history deletion command through Python just to achieve the same result. And that's done with cmds.delete ch for construction history equals true. And just keep in mind, in Python, your Boolean values, your true-false Booleans, are capital true and capital false, as opposed to other languages. All right, so let's just get rid of that. Run that script, and we can see that, there we go. We've successfully created this object and removed the construction history. All right, so there we are at the 50-minute mark. Thanks for sticking with me through this longer tutorial. My goal is to keep them a bit shorter than this, but we did have to get through the kind of some Python stuff, how to get set up with the script editor and all that. So thanks for sticking with me through this one. And yeah, this is absolutely essential information preparing for the first assignment. So whatever you are not absolutely rock solid on, go back over the tutorial and review, all right? And again, as I've been saying throughout, Google is your friend with the MyPython API. You're going to be Googling stuff all over the place to just determine how to use some of these API calls. All right, so that's it for this one. Thanks for sticking with me through this, and we'll see you in the next tutorial.